Hi geometry students, this is Miss Graham, and today we are going to be looking at section 12.2. This section continues to focus on flowchart proofs, but we're also going to be introduced to another type of proof, the paragraph proof. Your teacher has given you the notes that we're going to use for today instead of the textbook. I have also attached them to my calendar, so go ahead and pull them out. We're going to start off with example 1. In example 1 here, we can see we're going to write a paragraph proof for the following. So we have two pieces of given information. We have that MA is parallel to HT. So what I'm going to do is I'm going to go ahead and mark that on my figure right now, that MA is parallel to HT. I know that's the beginning information that I'm going to start with. We also see we're going to have another given where we have angle ATM is congruent to angle HMT. So we're going to come back to that in a little bit, but our goal is to prove that MA is congruent to HT. So we kind of have to start thinking out loud of how we would approach this type of problem. We know that we're writing a paragraph proof, so that means we are really taking what we would have in the 2-column proof, our statements and our reasons, and we are putting them in words and having them kind of all mixed together so it has this one nice paragraph that goes from our given information to what we are trying to prove. So let's start off with that given piece of information that we have, that first piece of given information. So we can start off our paragraph proof by saying we are given that MA is parallel to HT. So let's start off with that. So we are given that segment MA is parallel to segment HT. So let's start thinking about what do we know if those two lines are parallel to each other. Well, what we could do is we could actually extend MT a little bit. So let's imagine that we're extending this line a little bit and think about angle relationships, those that are essentially touching the two parallel lines. So what we know is that angle MTH, so this angle right here, angle MTH, would be congruent to TMA, this angle, because of alternate interior angles. So we can say we are given that MA is parallel to HT. So that means we're going to say our two angles are congruent through alternate interior angles, all right? So that means that angle MTH is congruent to angle TMA by alternate interior angles theorem. Now, we were able to prove that an angle out of our two triangles is congruent. So now we have to think, what other piece of information can we use to prove that, well, essentially our two triangles are going to be congruent, but then we have to additionally go past that and say that there are two segments on the triangles that are congruent. Again, we're probably going to use that corresponding parts of congruent triangles are congruent. We're probably going to use CPCTC to help us out with that. So to continue on, let's look at maybe the other piece of given information. So this is our other given here, that angle ATM is congruent to angle HMT. So we should probably mark those on our figure. That ATM, and I'm going to mark it with two congruence tick marks to distinguish from the other one, is congruent to HMT. So let's go ahead in our paragraph proof. Let's say that's what's next. So we can say we are also given that angle ATM is congruent to angle HMT. So with that piece of information, that's another angle in our triangle, right? That we're proving from each of the triangles is congruent. So right now we have angle, angle. We know we can't do that other third angle. We know that doesn't prove triangle congruence, but we do know if we have the including side, the side that's between the two angles, right? We could have angle, side, angle. That would also work as a rule for us. So let's start to look at that included angle. Wait a minute. We can see right here that through our reflexive property, right, we know segment MT is going to be congruent to itself, right? We can see this from our diagram. So let's start off with in the diagram, MT is congruent to MT since it is a side in both triangles. And then we can kind of say in parentheses, this is through the reflexive property. All right, so that gives us our angle, side, angle, right? We can do that. Now we could also say angle, angle, side as well, but I mean, we really want to stick with listing each of the given piece of information in the order. We have an angle, we have a side, and we have an angle. So we're going to do it by angle, side, angle. So that's kind of our conclusion we're coming to. So we can say, therefore, triangle MHT is going to be congruent to triangle ATM through angle, side, angle. And if you want to write that in parentheses, you can. You don't need to. The abbreviation works well. I just like to remind you of that. Now, keep in mind, we proved that the two triangles are congruent. But think about what's our ultimate goal, right? We want to be able to prove, we want to be able to show that side length MA is congruent to side length HT. So if we know the two triangles are congruent, we can say that the corresponding parts of the congruent triangles are congruent. So therefore, we know, since the triangles are congruent, that MH will be congruent to AT through CPCTC, which again, that's corresponding parts of congruent triangles are congruent. So let's go ahead and write that down. We're going to say, since the triangles are congruent, then MH is congruent to HT through, and I'll put the abbreviation CPCTC, but also write in parentheses that corresponding parts of congruent triangles are congruent. And then ta-da! That is our paragraph proof. Woo! All right, that was a little bit of a tough one, and we might have been introduced to, that little bit of that new rule at the end where corresponding parts of congruent triangles are congruent. So a lot of the times we'll have a new proof every single time we work through a problem, but as you can see, if we look down below, right down here, we can see that we have a similar question to what we just did. We're given almost the same pieces of information. However, we have a different proven as well. So it's going to be similar to what we just did in our paragraph proof, analyzing and thinking about, okay, what three pieces of information can I use to prove congruent triangles? And then our proof statement's a little bit different at the end. So here's what I'm going to have you do. I want you to go ahead and try this flowchart proof below, looking at the top one as a reference. I know it's a paragraph, a little bit of a different format, but I'm going to give you a little bit of time right now to kind of play around and see if you can come up with how you would be able to do this flowchart proof. So go ahead and pause the video right here, and we'll come back together and talk about what you came up with. All right, let's go ahead and start discussing what you wrote down. So I have some piece of given information that we know 2 lines are parallel to each other. So I'm going to go ahead and mark that on my picture here. So I have MA is parallel to HT. Now, there's no given information out of this that we automatically know if it's a side angle or side. So I know I can't put it into these spots right here. I know I have to put into this spot right here because we have to at least get to one more step to prove if it's an angle or a side. So I'm going to go ahead and write down MA, not congruent, is parallel to HT. And right below, I'm going to say that's our given information. Now, think about what we did last time. What we did in the problem above, where we could look at this line, extend it, and say, do we know any information about any angles that are congruent? Yeah, we did. We saw that angle MTH. So we saw that angle, let me try that again, angle MTH, this angle right here, MTH, was congruent to angle TMA. And we knew that was through our alternate interior angles theorem. Okay, so that way we were able to prove that we had an angle. So sometimes I like to put what letter it is out to the side here so I can keep track of that. All right, let's look at what we have next, maybe one of our givens. So looking at our given, it's a little bit different from our one that we have above. So it's angle MAT, so angle MAT, this angle, is congruent to angle THM, that angle. So let's go ahead and write that down. Angle MAT is congruent to angle TMH, and we can say that is our given piece of information. Looking good, and we automatically know that that's an angle as well. So keep in mind, as we're going through this, we have 2 angles. For it to be angle side angle, we'd have to prove that this side is congruent to that side. Right now, there's really not enough pieces of information where we know that. The only thing that we actually really know is kind of what we did before, where we have this side, this mutual side, being shared. So we can see that the side is going to be congruent to itself, right? So looking at this, we know that segment MT is congruent to segment MT. And we know that's through the reflexive property. So we know that's a side. Again, we have to keep in mind the order in which we're given things. We have an angle, and a side, right? Ironically, it's in a similar order for this angle, side, but pay attention to where it is on our triangle, right? The side is not between the 2 angles, so our rule is going to be angle, side. So I know that's what I'm going to be working up to. I have all those pieces of information, so therefore I can show that the 2 triangles are congruent to each other. So I can go ahead and start writing that down here. So we know that triangle MHT is congruent to triangle TAM. And like I said, you can pick the order in which you want to put the letters of your triangle as long as they match each other in the same order as before. So we know that's through angle, side. Looking beautiful. Now we have this last part down at the bottom. All right, so in order to prove our final statement, right, in order to prove this final idea of side length MH is congruent to AT, right? Our goal is to prove that these 2 sides are congruent, right? We can do that through CPCTC. That's corresponding parts of congruent triangles are congruent. That means if the triangles are all congruent, right, as we proved right up above, right up here, the triangles are congruent, then we can say any of their corresponding parts will be congruent, which is where we can say MH, segment MH, is congruent to segment AT. Look at you! We're getting so much better at these proofs, and we were even introduced to a new type of proof, our paragraph proof. Now, you can have a favorite style. Maybe some of you like the 2-column proof because it's nice and organized. It goes from top to bottom. Maybe some of you like the flowchart proof a little bit better because you can see how ideas flow into each other. Or maybe you're a paragraph person. You just really like to write your ideas and thoughts down. Either way, we've been practicing a couple different ways so that way you can have your favorites and you can know which ones you want to get better at, and maybe even got practice with how we can prove triangle congruence out of all 3 of these methods. All right, cool. Let's go ahead and go to the next page. We can see example 3. Ooh, now we want to go back to our other method we haven't used yet today, the 2-column proof. All right, that's right. Okay, so we have a couple questions that we're going to answer afterwards, numbers 4 and 5. But let's go ahead and zoom in to look at example 3, where we're going to write a 2-column proof over our given piece of information. All right, let's go ahead and read example 3 information. It says, write a 2-column proof for the following. All right, so we know if we're given 2 pieces of information, we can say them all at once or we can divide them up into parts. I like to break them up into parts so I can still finish up and follow through on one thought at a time. So let's go ahead and write that down. And our statements are first given. CD bisects, that's one of my favorite words, right? Because we kind of know what reason's going to go along with that. So CD bisects AB. And we are going to say that is given. So really, we know when CD bisects AB, right? That means it cuts it exactly in half. So what do we know? Well, this line cuts this line exactly in half. So AE will be congruent to BE. So let's go ahead and write that down in our next step. It kind of builds off of each other. So for step 2, we're going to say that AE is congruent to BE. And like I said, pay attention to how you're reading each of these lines, right? We're working inward to kind of this right angle type looking thing. We're working inward to this kind of right angle type looking thing. So we know it's going to be through definition of bisect. Definition of bisect, right? Because we have this keyword right there. Okay, cool. All righty, let's see what else we can do. Well, wait a minute. Can't really do anything else right now. Right? We proved that these 2 sides are congruent. So wait a minute, we're given a side that we're working with. We proved that. Woohoo! So let's see what else we can actually work with, right? Let's look at our next given. All right, angle A is congruent to angle B. All right, maybe I should mark that down. Angle A is congruent to angle B. And I'm going to go ahead and put that in my 2-column proof. I'm going to say angle A is congruent to angle B. And our reason is that it is given. Oh, aren't the givens so nice? It's just so nice to just put that in there. So wait a minute. With our given, we already have another piece of information. We have an angle now. Boom. So we have a side, we have an angle. Ooh, oh boy. Either way could go. It could go for an angle, could go for a side. We got to figure out what we have, right? Okay. So I guess what we have to do, right, is think about what pieces of information do we know that we can visually see and visually assume from the picture. So think back to those simple things that we can assume. Well, one thing for sure is we know vertical angles. Those angles across from each other, boom, those will always be congruent. So guess what? I think that's our 4th statement and reason that we can say angle AED, so angle AED is congruent to angle BEC. And that's going to be through our vertical angles theorem. And hey, guess what? That proves our last reason, our angle. So looking at our picture, right? We have an angle, side, and an angle, right? That side is between the two angles, same as over here, angle, side, angle. So we know that we are going to prove that those two triangles are congruent through angle, side, angle, all right? So I know that I can say triangle AED is congruent to triangle BEC through angle, side, angle. Alrighty, woohoo! On to our last part where we are going to prove that angle D is congruent to angle C, right? That's our last rule to show that this angle is congruent to that angle. So we know that angle D is going to be congruent to angle C. Remind me, through what again? That's right, the CPCTC postulate, where its corresponding parts of congruent triangles are congruent. So that way we can prove that any part of our triangle is congruent if the two triangles are congruent. Well, nice job with that one. We only have to hit up 2 more questions after this. And you know what? I bet those are going to be building off of different ideas of statements and reasons. So let's go ahead and zoom in onto 4 and 5. So keep in mind 4 and 5 are going to be their own questions. They're not going to go along with the proofs that we just did, those first 3 examples. So let's look at number 4. It says, if the first statement in a flowchart proof is BX, and that is a ray. If you can't see that tiny little arrow on the end, that is a ray. All right, so BX is the bisector of angle ABC. It then says, what should be the second statement in the proof? Well, something that might help you out is to draw a picture. All right, so let's try drawing a picture first. So let's start off with, we have angle ABC, and we have this ray of BX that goes through it. So I can see that I have A, B is going to be my vertex, C, and then we have BX is the bisector. So think about, what do we know when we have a bisector? Well, don't we know that these two angles are congruent, right? Bisector means it cuts in half. So think about what our second statement in our proof should be. Go ahead, you write it down. What do you think that statement should be? All right. I wrote down that the two angles, angle ABX, should be congruent to CBX. Now, if you wrote the letters in a different order, that's okay. I just decided to choose this order and this order, but either way works. We are able to prove that those angles are congruent to each other from our previous statement. So nice job with that. Let's try one more of these ideas, where now instead of the statement, we're going to see if we have one of the theorems or definitions. So it says, which theorem or definition justifies the statement, if E is the midpoint of AG, then AE is congruent to EG? Maybe go ahead and try drawing a picture to help you figure this out. I'm going to go ahead and do that as well. So I'm going to draw my picture. I'm going to draw my line. E is the midpoint of AG. And we're showing that these are congruent to each other. So which theorem or definition do you think justifies this? All right. Before, our key word was bisector, right? So we knew exactly that we were looking at cutting an angle in half. Here, our key word is midpoint. So guess what? For us right here, we are going to have definition of midpoints. That would be our theorem slash definition slash that would be our statement that we are working with. All right, so nice job on today's note. Even though you don't have any homework tonight, I want you to start looking at our calendar and figuring out, okay, what can you do to start to review for our fluency check coming up later on this week? If you don't have me as a teacher, I'm sure your teacher has some other resources that they've posted for you to start planning for our next fluency check. All right, have a great rest of the day.